Binomial distributions, AP Statistics, Lesson 6-2. Okay, our objective for this particular one is, whoops, missed it. Here we go. Students will be able to identify a binomial situation and construct a binomial probability distribution, determine the probability of a particular outcome or group of outcomes, and to determine the expected value in standard deviation of the distribution. The question that I need you to think about is this a binomial situation? And how likely is each or any outcome? Okay, so we have a little bit of vocabulary. These are 3 words, not much this time. Binomial distribution, combination, and factorial. Combination and factorial, both mathematics terms that you may have already seen before, but I want to kind of review them really quickly before we talk about the binomial distribution. Okay, so combination is technically the number of unique groups of k items that you could choose from a larger group of n items. For example, if I have a class of 20 students, how many unique groups of 3 students can I choose from that? So, and there is a formula for it. It is the combination of n items taken at 20, like this would be 20 items taken at 3 at a time. Or it can be written like this. This is the way that I learned it way back when. This is the way it is, that a combination is usually shown in probability problems. So you'll be seeing this more often, but I do want to remind you that it looks like this, and it also looks like this on the calculator. And what it is the factorial of n divided by the factorial of k times n minus k factorial. Well, what's a factorial? That's this little exclamation point. It's not really an exclamation point in math, it's a factorial. So n factorial stands for n times n minus 1 times n minus 2, and I would go on, and times n minus 3, n minus 4, all the way down to 3 times 2 times 1. So if I were doing 20 factorial, like if I had a class of 20 students, I would be 20 times 19 times 18 times 17 times all the way down to 1. And that would be a lot of work, but thankfully our calculator has it. So I'm going to give you the example that I just said. If I were trying to find out how many groups of 3 I could pick out of my 20 students, I can put that in my calculator by doing this. Oops, there it is. Let's do it again. Okay, so the first thing I had to do is put in the n. I had to put 20 in first. Then I go to math, curse over to probability, and then the third one is the combination. So I hit number 3, and I'm taking 3 at a time, so 3 again, and then just enter. That means that there's 1,140 ways I could choose 3 people out of a class of 20. Wow. Okay. Anyway, so that is what a combination of factorial is. And that will help us as we learn about binomial distributions. If you remember, when we're talking about distributions, we're talking about the probability of any one outcome, or any outcome. So, and there are some certain situations that can be called a binomial. And I'm going to give you the characteristics. Binomials have to have 4 things, and it goes with the acronym BINS. The first one is that it has to be binomial. And what I mean by that is that if you look at the prefix bi, it has to have 2 outcomes. Each trial has to have 2 outcomes, either a success or a failure. You're flipping heads and you're looking for the number of heads. Those are your successes. If you are rolling dice and looking for the number of 2s, that would be your success. Okay, so and everything else would be a failure. Okay? And then the second one is that they have to be independent. Each trial has to be independent. The third one is that they have to have the number of trials has to be fixed. I'm going to roll my die 4 times. I'm going to try to make a 3-row 10 times. It probably would take me 10 times. Number of trials is fixed. And then the last one, S, is that the success probability, or the probability of a success, is the same for each trial. Is the same for each trial. Okay, so, and the other thing that we need to know, so those are the 4 things anyway that are binomial situations. So we could think of something like maybe there is a 43% cure rate for a particular type of medicine with cancer treatments or cancer patients, and you're looking and saying, okay, well, I'm going to have I have 5 cancer patients. What is the probability that they get well? Okay, and you can say, okay, well, between 0 and 5 of them are going to get well. That is your number of fixed trials, and we know that each of them independently are taking their medicine, so it's an independent thing. They either get well or they don't, which is your 2 outcomes, and the probability of a success for each of those, each trial, or each patient in this case, would be 43%. So that would be something that would count as a binomial situation, and I could do a binomial distribution with that. When we do binomial distributions, remember we have x as our random variable. Our random variable stands for the number of successes. Okay, so that's basically what a binomial distribution is. So let's look at some examples of binomial. So first off, when we flip coins, we can pretty much say there is a 50-50 chance of it landing on heads or tails. So that one is one where my success and failure is equally likely. When you have this kind of situation, we actually could use Pascal's Triangle to help us figure out what our distribution is going to be. Because here is Pascal's Triangle, and just to remind you, each number...
We are doing quarterly inspection, fire alarm. If it should go off, please disregard. Thank you.
And, okay, each number is just the sum of the 2 above it. So this 2 is just the sum of this 1 and 2. If I go down here, 4 is the sum of 1 and 3. And I could make another line if I wanted to, but it always ends on 1, and then 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is still 10. And then I have 5 and then 1. So I can continue making Pascal's Triangle as long as I need to. So I can use this for binomial situations, as this can actually tell me the outcomes. So for example, if I flip a coin once, so for my first one, if I flip a coin once, I have either a heads or tails, and there's one outcome of each. If I flip a coin twice, so that's the second time, I have 3 different outcomes. I can either have both heads, heads or tails, tails or heads, or both tails. So this gives me that one. So if I'm looking at the number of heads that I would have, I could go by that. And so forth and so on. I can do that. So for example, if I flip a coin 4 times, and here's my 4th time, and I want to think about what the outcomes are. The number of heads, number of times I get heads with 4 coin tosses. The number of heads I would have would be between 0, 1, 2, 3, 4. And I can go across here and to tell you how many outcomes that I could possibly get. So there's 1 way I could get 0 heads. There's 4 ways I could get 1 head. 6 ways, 4 ways, and 1 way. Okay? In total, there are 16 outcomes. So each of these would be over 16 as far as the probability. And if I added them all up, I would get 1. So this becomes my probability. This is x, and this is the probability of x. That becomes my probability distribution. Unfortunately, in most cases, you don't have equally likely outcomes of success and failure. Much more likely is it's a percent other than that. So we have to do something for that. Thankfully, there is a formula. So when it's not equally likely, we can use this, where I'm talking about x equaling k, and when I want a specific number of outcomes, that the probability that x equals k is the combination of n, and remember that's your fixed number of trials, taking k at a time, and p is your probability of success to the k, which is of course the number that you're looking for, and 1 minus p, which is really your failure rate, to the n minus k, which is the number of failures you're going to have. So here is an example. Example, 10% of the girls surveyed that they rarely or never wore their seatbelt. What is the distribution if you randomly select 3 girls? So if you think about this, and if you remember, we actually had this problem when we were just doing probability distributions before, and we figured out the probability of each outcome and then added them together. Well, this is actually much shorter. They either say they wear their seatbelt or they don't. So you have a success or failure. You're choosing 3 girls, so you have a fixed number of responses. I'm going to assume that each girl's response is independent, which may or may not be a good idea. And I'm going to also know that my success for any one, each time I ask the girl, it's a 10% chance that she is going to say yes or no. 10% chance she's going to say, no, I don't wear my seatbelt. So here we have x is the number of no's, and I have nobody could say yes, or nobody could say no. 1 person, 2 person, up to 3 people could say, no, I don't wear my seatbelt, out of 3. Okay, so the probability of x, I'm going to go ahead and use that formula, and I'm going to show you how to do it on the calculator. So for the first one, and I'm going to write it out here for at least the first one. The probability that x equals 0 is, I have 3. I'm going to look at it 0 at a time. Whenever you have 0 there, that's in the bottom of the combination, there is one way to do that. And then I have p, which is 10%, so 0.1, to the number that I'm trying to see, which is 0. Remember, anything to the 0 is 1. And then I have 0.9, which is my 1 minus p, which is my failure probability, to the 3, because we're saying all 3 are saying, oh yes, I wear my seatbelt. Okay, so I can put that in the calculator. Now I'm going to go ahead and put the whole thing in there, so here we go. Clear it out from what we did before. We're taking 3 combination, 0 at a time, times 0.1 to the 0 times 0.9 to the 3, third power. And I get 0.729. Now I'm going to do the same thing now with p with x equals 1, x equals 2, or x equals 3. Okay, so I have done the whole probability distribution, and I'm hoping that you can see that I actually did some of this in the calculator as well. I did all the problems in the calculator, and I came up with these numbers. This is my probability of x, and if I add that up, it equals 1, which is what I want it to do. I want you to also notice that it's the same as it was when we did the problem when we weren't calling it a binomial distribution. So this gives you the same answers. As long as you have a binomial distribution, this works out the same. So that's great. So wonderful. So, but what if I'm not really worried about any specific answer? What if I'm more worried about at least one person is going to say that, or less than, or what's the probability of that less than 2 people are going to say that? I can find that out as well using this particular method. And I'm trying to get my, here we go. Okay. So, well, the probability that x would equal 2 of this, I would just look at the 2 line and say, oh, that equals 0.027. And the probability that it would be greater than 2, that x would be greater than 2, or equal to 2, would add these two together, because equal or greater than 2 would be 0.027 or 0.001. But I also wanted to show you how to find that on the calculator. Okay? Or 0.28, I guess that would be actually 0.28. And on the calculator, there's a way to find the binomial distribution of both of these. So for 2, first off, I'm going to go to second distribution, which is right above the vars. Go all the way down, and it's a ways down. It's actually A. Binomial PDF, which is the binomial probability distribution function. Okay, and so I hit that, and in this, so this is, the words are, it looks like this, if you can't see it on there, PDF, and that we got to there by second distribution. Okay, so binomial PDF, and then what they want in here is the number of trials, the probability that any of them are a success, and the number that you are looking at for the success. So that's the x. So that's how they want you to put that in there. So in this case, if I wanted just 2, I would put, the number is, I'm choosing 3 girls, and I want to choose them, I want the probability of any of them saying yes is 10%, and I want to know how likely it is that 2 will say yes. So I can do that, and I enter, and it gets 0.027. So that is another way, without using the formula, that you can get the information from the calculator for that. I'm not quite sure which one's easier. Okay. However, when you have to find a group of them, it might be easier to use this and this. So in this case, I'm not going to go to binom PDF. I'm going to go to CDF, which is the cumulative frequency. So I want to know that the probability of greater than 2. Well, the calculator will give me cumulative from 0. So I have to realize that greater than or equal to 2 is the 1 minus the probability of x is 1 or less than 1. Okay? So I'm going to have to remember that. If I'm going to look at a group of probabilities, I need to know where the cutoffs are. Alright, because it only goes from 0 to the number that you want. And I'm going to want 1 here. So I'm going to go to binom CDF, the same way, second distributive, and go down, because it is a ways. I think this one is B. Yes. Okay. Hit enter, and this time I'm going to use it. They do the same thing. They want X, P, and the less than or equal to what X. So we're going to say 3 1/10 or 10%, and I'm going to say less than or equal to 1. I'm going to get a comma, and that's going to give me 0.92. Now remember, that's this, so I have 1 minus 0.972. I'm going to do 1 minus second answer and get 0.028, which is what I got using the chart. So you can use either way. You can do the calculator or that. Now, expected value. We've done all these fancy formulas to get the distribution, but the expected value and standard deviation is quite easy. When I have the expected value, remember, expected value is the same as the mean. And for a binomial distribution, that's just the number of trials times the probability of success for those trials. And that's all I have to do. The standard deviation is the square root of the number of trials times the probability of the trial times the probability of a failure. So I have just n times p times p minus 1. Okay, so I have an example, one more example for us. Dolores makes 65% of her free-throw shots. What is the probability that she will make 7 out of her next 10 shots? What is the probability that she will make at least 5? And what is the expected value and standard deviation for her next 10 shots? So let's do one at a time. And we need to remember, first thing I want to do is I want to assign all my things so I know what everything is. So the number of trials in here is 10. The probability that any of them are successful is 65%. So I'm going to change that to a decimal, 0.65. And in the first one, I'm looking at x equals 7. X equals 7. So I can go ahead and put that into my formula. The probability that x equals 7 is 10, the combination of 10, taken 7 at a time, times 0.65.
Ms. Bullock, please meet your parents for the conference at 6:38. Ms. Bullock to 6:38. Thank you.
6.5 to the number that I wanted of successes, and then 1 minus 0.65, which is going to be 0.35, or 35%, to the number of failures. So 1 minus, or 10 minus 7. So if I can put that into my calculator and find the answer. I'm going to clear it out first. 10 math probability 3 and then I put 7 times 0.65 to the 7th power times, this should be minus 0.65, times 1 minus 0.65 or 0.35 if you want to put that in there, to the 3rd power. And my answer is 0.252, and that's the probability. So there's a 25% chance that you're going to make, that Dolores will make that 7 out of 10 shots. Okay, so that's part 1. Part 2, what is the probability she will make at least 5? Probability that x is going to be at least 5, or greater than or equal to 5. Well, that's going to equal the probability, or 1 minus the probability that she will make 4 or less. Because remember, one is the complement of the other. So probability, because we want to go from 0 to 4, so we can put it in the calculator that way. So I'm going to use my other function to do it this way, which means I'm going to go to second, distribution, go all the way down to, binomial CDF, hit enter. My n is 10, because she's making 10 shots. My P is 0.65 because she makes it 65% of the time. And my X is 4 because remember that, and this is cumulative, so it's going to go from 0, 1, 2, 3, and 4. And that's going to give me that number, so it'll be 1 minus that number. And this is 0.094. And I'm going to say, okay, well I want 1 minus that number. So the chances that she's going to make at least 5 shots is 90.5%. Okay? Now, 3 is the expected value. Expected value is just N times P, or the number of trials, 10, times the probability of success, which is 0.65. So my expected value is going to be 6.5. And then my standard deviation of X is just the square root of the number of trials times the probability of the trials times really the failure, the probability of failure, which is 1 minus P. So that's going to give me the square root of 10 times 6, or 0.65 times 0.35. So I'm going to do that. 10 times 0.65 times 0.35. All of that, I'm going to take the square root of that. Probably could have done that in a much better way, but oh well, life goes on. So my standard deviation is 1.51. And there you have it. Hopefully that will help you complete your assignment, and I will see you in class.